and today we want to talk about the exercise that we want to do 9.7 before doing the video. We want to introduce ourselves. My name is Yahya Hussein Omar. My matric number is 191362.
And my name is Abdullah Khan and my matric number is 191381.
My name is Connie Juan and my matric number is ES02604.
Okay, after introducing ourselves, so we want to start our question. So Abdullah can already start.
Okay, so in this question 9.17, so we are going to talk about this question considering the principal paragraph, laminar flow and the flow of the oil flowing slow down in the infinity vertical wall. So the oil film, the thickness is h, and the gravity acts in the negative direction. So there is no applied force, pressure, and the gravity also that the flow and the oil falls by gravity alone. So in this question we need two things. First of all, we need to calculate the velocity and the pressure, and the second one is which is the fill in the oil and film, and also need to sketch the velocity p for the film, and you may be neglect change in the hydrostatic pressure of the surrounding. So now I'm going to pass the explain the solution for my friend. So.
Okay, now the solution is, all we know is the first plates are infinite in y and z, and the second flow is steady, and this is equal 0, and parallel flow, so we know the u is equal 0, and the pressure at atmosphere is constant at free surface and no pressure. 2d v equals 0, and this is equal 0. And the sixth, gravity acts in the z direction. And then the boundary conditions. The first, no slip at wall, so we know x equals 0, u and v, w all equals 0. And then it's at the surface, and we know x equals h. Okay, now.
Okay, so now we are going to do the third steps. So for this steps which we are going to explain, it's also we are going to see here, because the flow in the steel is equal to 0. So mean here we have the 0, and here also the 0. We are going to drop it from the equation. So therefore we have the W equal to Wx, which means we have some specific values which we are going not to change. So since we have the V equal to V0 and V Y, and the gravity doesn't act in the X direction or Y direction, it's mean like we don't have any force in the X direction and Y direction. So the X and Y momentum equation, we are going to do the momentum equation which we have, it's from the previous, from the fluid which we have done. So here we have the pressure, and also this is the equation. After that we are going to drop some of the equation, because due to we have 0 volts, and we have 0 distance, and we have 0 direction, because we don't have any force. That's why we are going to sweep the dw and also dw dx, also dw dy, also dw dz, because in this all direction we don't have any force. So after that we are going to find the equation, which is the solution, solve the differential equation. After we differentiate all, after we cancel all which we no need in the equation, we are going to find this equation. W equal to Pg, which means the gravity, and over 2m x and also plus C1 and plus C2. So here I'm going to pass the last steps for my friend Yahya.
Okay, my part I'm doing is step 5. We are just applying the boundary conditions. For the boundary, the first condition, it was like this one. Because it says W is equal to 0 plus 0 equals C2 equals 0. So C2 equals 0. So we will get this formula. So since the x and less than the height in the frame, the view always is negative everywhere. So the last step we are doing is step 6. We are verifying the result. So to get the last result. So when we say this x equal this theta x divided by h, and we will get w ub here squared. So when we want to normalize velocity profile. So the result we already get is we get this the normalized velocity profile is this one. So that's all for our group, and our group is group E. So thanks so much, and that's all.